Another important control structure in JavaScript and in programming in general is loops. When we create our logic, there is often a need to perform a computation X number of times, or keep performing an operation while some condition is still true. For multiple execution of some logic, JavaScript implements something called loops. Let's see an example. Imagine we are writing a game and we need to move our character by 5 steps. And also imagine that moving a character by 1 step is some sort of computation. Right now, I'm just going to use a simple log statement to make it work. The log statement will say move character by 1 step. Let's say we need to move our character by 5 steps. And what would be the easiest way to do it? Of course, copy and paste this 5 times. Let's save it, see if it works. And it certainly does. While this does the trick, this is not perfect. Imagine if we need to move our character by 100 steps. We cannot keep copying and pasting these instructions over and over. For that, JavaScript offers us something called loops, and one of the most common loop implementations is a while loop. Let's see an example. I'm going to declare a variable, call it I, and I is a convention that's used for an iterator, something that keeps track of a loop execution. And I'll say while I is less than 5, log move character by 1 step. And also I need to add another instruction. I need to increment I on every loop execution. Let's save this and see if it works. Move character by 1 step. Now we see there is number 5 added over here. Browser is doing that to optimize the output. Essentially, this is the same output that we've seen before. Let's look closer at this. What this is going to do is it will execute the loop body over here, this code in brackets, while this condition is still true. This is a place where JavaScript checks the loop condition, whether it should keep going with the iteration. And in theory, if we did not have this increment operation, this loop would be going forever. Such loops are called infinite loops, loops that never stop. And this is usually a programming error. So I'm going to bring this back. And to make it more visual for you, I'm going to do another little trick over here. I'm going to say move character by I step. You guys should be already familiar with this construction from our strings course. Save this and go back and refresh. Let's see what the output is. All right, move character by 0 step, 1, 2, 3, 4. Great, this is what we wanted. I is an iterator. We're keeping track of our iterator in the loop. We're showing which step or which iteration we're on right now. And JavaScript is doing the condition check successfully and breaks out of the loop when this condition is false. Condition check can also be located under the loop body. I'm just going to grab this and I will say do something while I is less than 5, semicolon, and save. In this case, loop will execute at least once and then the condition check will follow. In programming practice, though, the first construction is used more widely. However, this is a working code as well. Just be mindful that with this construction, with do while loops, the execution of a loop body will happen at least once, and then condition check will be performed, and JavaScript will break out of the loop if required. Let's just verify if it works, refresh, and we see exactly the same output as before. Awesome. There is another, a bit more complex and more widespread structure of a loop, so-called for loop. Let me wipe this code and show you what I mean. I'll say for, and right now, just bear with me. I'll write some pseudocode for you guys. Just declare the loop body, and I'm gonna say for start condition check, step, do some stuff. I'll comment this out. Let me explain you exactly what I mean. This is how the JavaScript for loop declaration is. On the first position over here, we have a start declaration. Then we're declaring a condition check and the step. Let's write a practical example for it. I'll say for let I equals 0. This is the exact same stuff that we had before. And I is less than 5, which is the condition check. And our step is I++. On every iteration and increment I by 1. These should be semicolons over here. The algorithm of actions that JavaScript will take over here is the following. Declare a variable. Declare a start. JavaScript within the for loop will first execute this start instruction. It will declare a variable. Then it will perform a condition check at least once. It will verify that the start variable is less than 5 in our case. If it is, it will execute the loop body. In our case, it maybe will log move character by 1 step. And then after the loop execution, after the loop body execution, it will increment the step variable. It will do the step part. Let's save and go back and refresh. Yes, that's what we want to see. 5 outputs of move character by 1 step. And this instruction, it will keep going and going. Declare a start variable, perform a condition check, perform the loop body execution, execute the step instruction, increment I, do the condition check again. Is it still valid? Yes. Execute the loop body again, increment I, and so on and so forth. There are a few more things we can do here. Let me show you. We can stop stepping halfway if we'd like to. We can break from the loop execution conditionally. Let's use the construction that we learned in our previous video, the if construction. Let's imagine maybe our character is only capable of making 3 steps a turn. And if I am on the 4th step, I don't want to keep going anymore. I want to just break out. We can do this. JavaScript gives us a tool to do it. It's a break instruction. I'm going to say if I is greater than 2. Now, this will be the 3rd iteration of the loop. Why? Because on the 1st iteration, I is going to be 0. The 2nd iteration, I is 1. The 3rd iteration, I is 2. I is not greater than 2. The 4th iteration, I is going to be equal to 3. And that value is greater than 2. Breakout. Let's save this and see what the output of it is. Refresh. We made 4 steps, right? So maybe to make it 3, I either want to put this above our step-in instruction, our step-in computation. We made 3 steps. Or I want to change this number to 1. This is not very obvious, so I'm just going to keep the previous version of it. Perfect. Break directive completely stops the loop execution and passes the execution to wherever code follows the loop body, whatever comes after it. Save. Perfect. There is another lighter version of a break directive. It is called continue. Let me show you how it works. I'm going to substitute break with the continue statement over here. When we put it in the loop, it doesn't kill the execution completely, but rather cancels its current iteration, current step, and moves on to another one. Let's imagine, for whatever reason, we want our character to only take steps on the odd iterations. I'm gonna say if the division remainder of I is equal to 0, do not move, right? So if we are on the even number, do not execute this. Just continue. Just move on to the next iteration. I'll save this and go back to the browser. Let's refresh. And that's exactly what we wanted to see. Move character by one step over here. We have two outputs. We have two odd steps in our instruction. To make it more obvious, I'm gonna switch this a little bit. Save and refresh. Move character by one step, move character by third step, if you will. Only perform this computation on the odd I. So this wraps it for the loops. I highly encourage you again to go on the internet and search JavaScript loops, read about it, and I'll see you in the next video.